All right, Leland, how can people win $2,000?
How can people win $2,000? So if you're enrolled in an architecture program here in the United States, undergrad or graduate, and you've made a project in the past year that has integrated technology in some deep way that's, I don't know, hopefully like original, I would say. So maybe not the same kind of like panelization stuff that we see a lot of. Then please apply on our website for this award. And it's very simple. You just drop a link to the project hosted on your website. And by April, the winners will be announced. And there's 2K. So really simple process to
So,
apply.
what is the website? And we'll be sure to drop it in the notes. And why did you decide to make this award?
So it's a page on my website. So if you visit lelandjobson.com/prize, you can see more information about this award. It's called the Computational Design Young Voices Award. And my hope is to incentivize and platform the use of technology in architecture student projects.
모스트 보던 팟캐스트.
Sweet. I guess now is a good time to introduce our guest, Leland Jobson. Leland is a full stack developer, developing applications across architecture, construction, manufacturing, and real estate. He's currently working at NVIDIA, developing Open USD applications. He also teaches first and second year courses at Pratt as a visiting assistant professor. Welcome, Leland.
Hey, so great to be here and to meet all of you and have the time to talk about these cool things.
Amazing. And of course, we have our co-hosts, Minku and Alex. If you both want to say a quick hello.
What's up, everyone?
All right. So, like many of our guests on the show, you started your career as an architect. Can you tell us a little bit about why you chose architecture?
Yeah, I wasn't a great reader, so I read a lot of picture books pretty well into my teenage years. Like everyone was like devouring Harry Potters, and I was reading like those big books where they have like the blueprints of like spaceships from Star Trek and stuff. I loved that stuff. So I think just kind of by avoiding that kind of avoiding books and being more interested in art and pictures, I think I kind of ended up being interested in architecture and art. My father's an artist, so that was also a big influence in my life.
What kind of art does your father do?
He's a painter, but he's professionally an art director in advertising and publishing.
Well, it's interesting because, as we heard in your intro, you've kind of taken a technical path in your career, but did you go into architecture school with a lot of art ability?
No, I was, I think, good enough. I think that I was a jack of all trades. Like I liked to do sculpture. I did a lot of hand drawing, but I wasn't like quite good at anything. I wasn't exceptional in anything, photography, etc. And I think just by like pure luck, that turns out to actually be a pretty good mindset for being an architect.
What were you into the most?
I really wanted to make a video game like when I was a kid. So Halo came out and that was a huge thing in my town. We had like the LAN parties and everything. And I really wanted to make like the Master Chief helmet.
Mm-hmm.
And I couldn't like pause the game or like any cutscene, figure out how to extract like the 3D model and try to draw it. It would never be quite right. But did some research on the internet and I found, people were able to like extract the geometries of these things and through some script, like open up like the Master Chief suit and like discrete Gmax or something like that. It's just like, I think that's the predecessor to 3ds Max or maybe I got that wrong. So I got into like, how do I do this? How do you make a 3D model on a computer through trying to like hack together, like understand how video games work and that kind of thing.
Like this was pretty early on, right? Like, so while you were at school, were you more advanced technically than a lot of your peers?
I had a little bit of an edge because I was fascinated and curious by video games and the internet, how websites work. Just like I went off on a tangent when I was trying to research that Halo like Halloween costume thing, and I was going through a lot of message boards, and I really wanted to understand like how does a message board on the internet work? Like when you make a post, like where does that go? How is it still there? Like when you have a picture like next to the text, like how does that work? So my parents, gave me some really great resources. I'd go to Barnes and Noble and like kind of look at the books for a little bit, try to remember something, and then go home and try something out. So I had a little bit of an edge in terms of that I had contact with the subject matter, but I wasn't confidently programming until my second year in college. So I think I had the interest, and I had a little bit of the, I had the interest and the comfort with the technology. And then I think I really like sharpened my skills at school.
It sounds like you're really into the assembly of things. I'm curious, how come you went into architecture and not directly into computer science?
Yeah, I had, maybe high schoolers still kind of have this polemic, but I was not enthusiastic about school and taking tests and memorizing things. So the idea of going to art school just felt like quite liberating. Like it felt like any kind of like going into math or physics, things that I was really interested in and actually pretty all right at, just felt like it'd be more of the same, and I felt like I needed to kind of get out of that system. So architecture felt like it was on, it was in a different space, but it was still close to those kinds of things. It could still have, perhaps like math and programming in it. And fortunately, it turned out to be the case. I didn't know it when I was in high school.
So did you want to go to work for a gaming company while you're at architecture, or did you want to practice architecture when you graduated?
Yeah, actually, once I got into college, I really like fell in love with architecture. But up until that point, I think, I always felt like I was going to work at like a video game company or something like that. Maybe I would get my degree and then, model the buildings or something like that in like Gears of War or something like that.
Yeah.
But I don't know if a lot of architects, I don't know if a lot of those people making those models were actually architects, or if maybe they're more from like the special effects and film industry. But that's something I'd like to follow up on, if that's actually a reasonable career path.
I think it's an incredible story because I also remember that time period when we were all playing video games in our college dorms. And it was a moment when digital entertainment was becoming much more about the environments, like the spaces and the worlds that were being created in video games were just incredible. And they really started to become quite architectural at that time. I'm curious if there are any particular, besides Halo and Gears of War, if there are any other particular genres or franchises that really stood out to you and inspired you.
Definitely. So the thing about Halo and Gears of War is they were, multiplayer games, and the way that you can kind of dwell, that you would be in this virtual space with your friends and dwell in these kind of maps and play around, especially in Halo. Halo 1 had really large multiplayer maps, perhaps too large. And so you would kind of scoot around after school and like kind of find these little secrets and just kind of run around and shoot each other and drive vehicles everywhere and stuff. But if I had to give a specific title that people should look at, I'd say Mirror's Edge. Mirror's Edge is like a parkour game.
Parkour one, yeah.
That's highly architectural, and I think it's quite stunning.
That's a great pick. I think, you were, I guess, probably one of the earlier computational designers coming out of school, like finding that perfect intersection, I think, in your interest in technology, but also something that is now deeply ingrained in a lot of architecture practices. But for those folks who don't know what computational designers are, can you give us a little explanation of what computational design means and what attracted you to it?
Yeah, sure. So, as we all know, if there are architects listening to this podcast, the computer is pervasive in everything that we do. CAD facilitates drafting. So in some way, the computer has a really large part of every professional project, unless you choose to avoid it. And I would say that computational design is where something is infeasible without the computer rather than just facilitated by it. So for example, many people might have heard of computational design in the context of how to make a complex outcome, like a panelizing a curved surface. This is the canonical grasshopper example, the carrot, that gets a lot of people addicted to this stuff. So, you'll hear this problem. There's a curved wall. It might be the fenestration of a stadium, and you need to panelize it with mostly flat pieces, reticulate it for structure. When you do this with a computer, it's a lot less of a pain than if you were to create the model by hand. So that would be, in a sense, a good example for computational design. And that was my mindset getting into it, that I would be able to create these unique things. I wanted to stand out as a student. Kind of made sense, and I knew a little bit about programming, and I felt like this could be my thing. And although that mindset kind of started my journey down that path, I realize now that good computational design is about making flexibility in a project for changes, foreseen and unforeseen. And to put it in a more poetic way, I think good computational design is rectifying the uncertainties of the project with its soul. And the uncertainties might be the changing demands and externalities, design changes, etc., that affect the project.
But what is its soul then?
Yeah.
I think the soul is, well, what's the driving idea or characteristic that you want to convey with the project, the elevator pitch, etc. The spirit of a project. I guess, vague intentionally. I put it vaguely intentionally because I think there are many form factors that such a thing can have. It could be a partie, for example, as simple as that, or it could be a certain kind of experience that you want to produce.
It's really interesting that you put it that way, because a lot of times people feel like the technology is fetishized. It's used to create something that can't be produced in traditional methods, but nothing beyond that necessarily. So it's interesting to hear you, Leland, talk about actually trying to advance the soul or the partie of the project. I also want to make this clear for maybe non-design listeners as well. What were the main limitations of design before the computer came along, especially at this moment, let's say 2010, sort of a decade into the 21st century? What was really the advancement that was occurring at that moment?
So the story arc for this is that Frank Gehry saw technology from the aircraft manufacturing industry, I think, or was it the shipbuilding? It was one of them. And found that he could use, I think, like CATIA or something like that to produce a curved surface that he would have otherwise had a hard time doing in AutoCAD. I guess the thing about that was it was making the building realize the sketch and the kind of like curved stroke and the haphazard model that we've all seen on the Simpsons parody, and that kind of thing, realizing these dreams. So, we saw that, but I think that now that time has passed, I think that what the computer brings to the table are, on one hand, the bromide that we've heard before, that it's a time saver. It gets the rote work out of, drawing and erasing and stuff like that. So I think that's reasonable, but also there's a lot of discussion behind that. A lot of debate about the significance of that. And then on the other hand, iteration. I think that you can iterate a lot more through the computer, expressing a design on the computer, than you would by hand. You might be able to foresee many thousands of outcomes of a project and perhaps pick a better one. That also, I think, is fraught philosophically. Sometimes, your third one is actually the best one, and then the paradox of choice ends up getting you down the line.
Or even maybe the first one. Even maybe the first one. I mean, we were kind of the victims of that mentality, right? Like we were the human hands to produce the options before the computer ages.
So also, I guess like part of the reason why you're able to put a lot of these things very poetically is that you teach, and you probably have a lot of experience explaining this to students. So I'm curious, why is teaching so important to you, and how has teaching technology changed, especially in something like design?
Yeah, I'm a bit surprised by how it's changed. I felt like that it would increasingly have a larger footprint in the education, but it seems to be that it's on its own island. And to be completely honest with you, I don't exactly know why that is. I just have, I have some speculation on it, but teaching is important to me because it's a learning opportunity for me when I put things in a way, I think, and I see how it's received by a student. It shows me the kind of deeper, what it is that I'm actually saying. And then I have to put something in different ways to explain it differently to different audiences. And I think that it helps me kind of get that multi-dimensional feeling of an idea that really makes me think and go deeper and have a higher level of understanding about what it is. So I'm learning as I'm teaching, at least I feel like. And I think that part of that is that my sensibility and my ideas and philosophy are kind of being cultivated in the process of just explaining the same things about like how to properly draw and render something. So it's
maybe this is
I'm
a
the principal
place.
benefactor.
Maybe this is a place where I can solicit a hot take from you, because I totally do agree that it does seem like, as embedded as technology is in our everyday lives, especially in design, it does get put on an island. You see this in schools, you see this in companies. Technology is not kind of this foundational layer that's deeply embedded in the practice. So why do you think that is?
Yeah, I wonder, like, well, let's take a few. I think that education is really mimetic. I've heard I think that the glass half empty like way of putting that is that a professor can only really teach a student how to be them. I don't know if I fully agree with that, but it's it's worked its way into my brain. It's kind of stuck there, and I haven't removed it. But I think that the mimetic nature of education, meaning that like unconsciously or consciously, a student copies their teachers, especially in the liberal arts and arts where right and wrong are less tangible.
Mm-hmm.
Copy the faculty. They're there, right? They must have the right ideas. And so if there aren't enough faculty that are doing these things, then they're not going to be replicated. So and I think the uptake from the student side is possibly explained by that. So I guess why isn't it a big part of the agenda of architecture? Maybe technology's prevalence has ironically demoted it to the background. And, it's already there. Maybe the foreground should be something else.
Well, I think it has to do with sort of what you're talking about, Leon. Although I would say that a professor should be able to teach a student how to think like them. Now, and that's where I think the issue of technology comes into play, because I'm not expecting people at certain generations to be able to use this technology as the same way as other generations can. But I think that there should be some sort of dialogue between the student and the professor in terms of what if the goal or the concept is something we can sort of agree on and we should approach it. How can we get there? And if one generation can bring to the table certain technologies and the other generation can bring to the table other certain perspectives, then I think that's how it should work. Now, does it work that way? Absolutely not. I do think there's a ton of let's say gatekeeping or just fear of the unknown, lack of curiosity in schools, which I think needs to be called out, to be honest. It's kind of sad. And, you go in these places and they say that they're all innovative and they're all about the future and whatnot, but it's really unfortunate that it's not the case. But I do agree with you also. Just sort of the culture of institutions creates cultures where there's certain things that are celebrated because they're common amongst faculty. And if you have a sort of minority of faculty who aren't dealing with one technology or another, then they might be sort of relegated to the shadows. That's my hot take. I hope I don't get fired for that, but I think it's really true.
Yeah, well, you're not the only one. I mean, I think that I think there is a perspective amongst personnel that are tech savvy as being, the IT person, like, oh, can you help me? Can you help me plug my computer into the TV since you're so good at Grasshopper?
How to make PDF.
Yeah, can you help me save a PDF? I mean, it comes up, but I don't take it personally at all. It's flattering on me. I mean, but I also feel a little bit like, just like you said, like the prevalence of technology, the proliferation of technology, and also it's expansion, exponential expansion. I mean, especially with chat AI and this kind of stuff, like you have to be literate. You have to really understand how these things work, or at least start to get like in proximity of them. I think that, you want to navigate the terrain of the future of work. I think that you really have to understand at least these tools and then make a conscious decision of whether or not you want them to be a part of your voice or of your practice. But I don't think that you can turn your back on something without fully understanding it first. So I do wish that it were a bigger part of the education. At Pratt, we do have in our third semester of representation, students can get more into like twin motion and like workflows for moving information around between different platforms. Grasshopper, some people teach that. So it is a requirement, but I think that how much you get into that stuff is really about what faculty that you pick. And I was fortunate when I was a student to have picked some really great faculty who taught me a lot and imparted, to your point, their way of thinking on me and helped me stand on their shoulders.
Can you give us maybe top 5 software, like some examples of what you would recommend a student to start learning as you see it being a critical part of the workforce in the future?
Sure. Yeah. I mean, there's a lot you can do with Rhino and Grasshopper. I think what's interesting is like Grasshopper is a node from which many spokes come off of it. So getting acquainted and comfortable with Grasshopper in your workflows can bring you into Python, can bring you into now with like, my old colleague Sergey Pigok, made a really wonderful Grasshopper library called Swiftlet, where you can make API calls, web calls out of Grasshopper. Like it's the gateway to everything else. So I would say, it's the mega store Grasshopper is for all this stuff. So I would say absolutely learn it. And professionally, I think that like Twinmotion and Enscape, I think that Twinmotion might be a bit more utilized, although I've been out of practice, but it comes up a lot more on my end. Is great. I mean, like it's just a big part of the production workflow, and it's fairly easy to learn.
Yeah,
Gives
the
really good
real-time
results.
rendering software has really changed the game in design, just
Hugely.
to be able to visualize things much more quickly with much higher fidelity. I mean, I think this conversation, we have a lot to touch on with you, Leland, but it reminds me, Lebo, of when you're talking about the wall in one of your posts and how it's like if you don't try to climb that wall that is technology and you don't even attempt to scale it, you're just going to fall farther and farther behind. And my further critique is that there are certain places in the world, especially schools, where there's people there who are not incentivized to actually go out beyond their sort of comfort zone and learn those things. I think for people who are getting into architecture, it's a huge fallacy. It's a huge mistake not to try. Because the only thing you have to lose is your time.
Is steep, though. I think that's where a lot of people get stuck. And I do agree, like, Grasshopper was also my gateway drug into a lot of this stuff. I'm also surprised you didn't want to put Revit on your list.
Well, maybe
we can save
maybe I
that for part two.
I have a love-hate relationship with Revit.
But I think, it's interesting, right? Like, computational design is just like 1 foot down the technology path, but you have really taken 2 steps in right now as a software engineer. So I guess like give us a little like reasoning, like why did you take 2 steps into technology?
Because I feel that software has a greater ability to affect the kind of changes that maybe motivated students in an architecture program want the kinds of changes that they're interested in, that they think architecture can do. I mean, architecture now, unfortunately, its agency, I think, architecture's agency versus the architect's agency. Let me make a distinction. I think that the architect's agency has waned. I don't necessarily mean to say that like a software engineer could possibly have more agency than an architect, but I think that today a piece of software could actually have a vector to making inroads on something like social interaction. It's just like a crowd favorite in undergrad. They want to promote social interaction or shape interaction socially in a project. And I think that software, given the right platform or deployment, it could be integrated with architecture in some way, is more potent to actually addressing these kinds of things and more feasible professionally than the architecture practice. So that's a bit of a hot take. I don't know what you guys think about that.
I tend to agree. I mean, if we just talk about the use of software, like it's very hard to talk about design beyond the culture of design, beyond the people who are in that society. But everybody is using software to some capacity. And I think the basic function of software, besides efficiency, is to, as you're saying, Leland, sort of connect people, create platforms in which you can work and collaborate across things together. I know, like, for instance, AI, a lot of people are talking about its generative use for creating visualizations, but also in terms of how to create structures within society to make democracy flow better, or to make sure that participation can occur and things like that. So I think that you have to change your idea of what agency is. Is it building a building and making something appear out of the ground? Maybe then, coding and programming is not necessarily going to do that exactly for you, but it could facilitate the growth of other architectural outcomes down the road, which I think people are starting to get in tune with, especially because of the career opportunities that just exist there versus traditional practice. But at the same time, don't you think it takes a mental switch, a sort of adjustment of your perception of what an architect is to even entertain that thought?
Yeah, I don't think that I could sell that thought to my colleagues, to put it another way, or to an architectural program as an argument to integrate, like, my dream would be that architects are able to apply, we divorce the thinking, the big picture top down thinking and the bottom up lessons and this kind of thing away specifically from buildings into something that's more about perhaps like experiences, which is just kind of a blanket term for maybe many things. Maybe it's inaccurate and fuzzy, but in that way, I think that many different mediums become part of the education. So I would make a strong argument for that. And I think that the way architects think and the way that they have a need to producing propaganda and marketing, organization, the kinds of thinking styles, top down and bottom up. These are really great skill sets to have, coincidentally, as an engineer or in technology startups. Lebo and I were just talking about this. And I think that probably shares the same perspective. A lot of architects, are well cut out to serve as key personnel in tech companies, provided that they learn the tools. And I think that if they're competent at Rhino, Grasshopper, and yes, Revit, the elephant in the room, then I think making that switch becomes a little bit easier.
This may be a little off topic, but I see it more integration with software and actual real estate, the built environment. So maybe not too much in the process of making the building, but after when the building is built with the users and it's interfacing, the software interfacing its actual users is becoming more of a larger market. What's your view on those?
I wonder if I'm on a wait and see kind of perspective on that. I did work for a startup working on digital twins, and one of the spokes of that wheel was that, an architect may produce a digital twin of the thing that they create and then sell it or manage it as a new product in their business. And it's not a part, at least to my understanding, maybe you guys know better, it's not a part of the practice today, but it is a curiosity because I think that in a total design kind of way, architects can address the experiences of the occupants after the building's been built through these kinds of technologies. At least it seems like there's a vector there, but I think it remains to be seen, and I'd love to see someone try. I think WeWork was starting to get there. With some of the IoT stuff that they started. But of course, if they're trying to do too many things at once, just like a young architect.
Well, I think part of it is like the operational sophistication of the end operator of the building, right? Like you could have all these sensors there, they could be detecting data, you could be running analytics, but what is it all really for? Like if it doesn't actually impact a lot of the decisions you make on the building, then you're just kind of throwing money out the door. And I think digital twins is one of these, I feel like many technologies that our world has come up with that is a solution looking for a problem, and the problem hasn't yet quite manifested itself.
When there aren't high stakes when you're talking about an office, like in terms of, shutting the shutters on a window when the radiation of the sun is too high, or like, adding that one desk automatically when, one more person than usual comes in. What's the downside of that not happening? And it's that, the AC's on for slightly longer. But we're talking about tens or hundreds of dollars. But in a field like manufacturing, mistake, with this. And I think we understand this maybe from like, chemical, like industrial architecture, where like it's a huge part of safety and actually making the money and the processing. I think that's where digital twins become much more valuable, much more important. But yes, I agree, Lebo, that like in architecture, I think the argument is a little more difficult to make. But I wouldn't say 0%. But I'd like to see it as well. I'm a see it to believe it kind of person. So I think that the solution in search for a problem, a way of looking at it, is totally valid.
So I want to make an appeal for the digital twin at the urban scale, because I think that's where it's really valuable. And simply because you can't really, it's very hard to simulate something that's larger than a building. And if we can harness all that data and all that information that's out there and start to really understand the organism that is a city, I think it can be really helpful for sustainability, for participation, things of that nature. There are also questions about, governance and authorization and a sort of oversight over things, which is a bigger picture. But I think one of our issues right now in the world is we have to deal with the urban conditions that we've inherited. We're not really able to form new ones over and over. So I think in that case, technology could be quite powerful. And if it is just adjusting let's say the energy consumption of a couple buildings, but at the scale of a much larger city, I think you could see returns there. And maybe that's something you learn from software, because it's name of the game with tech is all about sort of market size and scalability.
No, I love that. I love the idea of like the living city, made even more literally with this kind of stuff with IoT. I wonder if you guys have talked to any of the Sidewalk Labs people to see if they had what they were thinking about this. They seem like the right people to talk to about such ideas.
No, we haven't yet, but I think we definitely need to mark it down. Yeah.
They'd be better than me, I think. And I think maybe a question I would have then, if I could stick one into that future interview, would be, is the architect a part of that? Even a part of that, or is it, the PhD for, I don't know, environmental science? I just made that up. I don't even know if that's a legitimate major.
But I guess like when we were talking about this conversation, one of the things that you brought up that I felt was really compelling, something that I also think a lot about through kind of learning programming, through learning how to work with data, is the role of language in not only design, but also representation, but also in computation, how learning a language really impacts the way you think about problems, but also how you're able to express solutions with those problems. So I guess, can you give us your take on the language of representation and the language of technology and how you bring those two things together?
Yeah, this is such a great question. I mean, you could have a whole separate episode about that. I mean, language is really everything and the most important thing. It's a really hard lesson to get across, like, to students, and I'll try to describe that. So I didn't start thinking about the role of language in architecture, apart from like, is it a Doric column or an Ionic column, until I had a required reading to read Kevin Kelly's, the editor of Wired, has a book called What Technology Wants. And in that book, towards the beginning, they're talking about defining what a technology is. And there's an argument that language in some way is a technology. But in describing language, there's this passage, it's really stunning, that says that, language is like a magic mirror that reveals to the mind what the mind thinks. I think that's really beautiful. And so the great idea is that representation, language is generative. When you hold the thing you were thinking about over here, you can create a new thing here in your mind. It's now, that space has been vacated. So you can kind of produce these layers. So that's one role of language, and the importance of language and the importance of drawing and thinking. I think that when someone says thinking through drawing, I think that's kind of like the atom of what's happening in that process. The other important role of language is the medium and the message, the Marshall McLuhan famous statement, which is that the way that something is expressed is part of the content. So when you express something, use language in a certain way, the total artifact is composed in part with that expression. So I didn't talk about programming specifically, but I was wondering if you guys had any thoughts about that first.
First of all, I love the quotes. I think that a lot of times in design, especially, we emphasize the product over the process. But as designers, we also know that you only reach the product if your process is on point. And for us, given that our instruments of services are drawings or images, diagrams, etc., we move towards that product by going around those instruments of services as part of our process over and over and over. And, we've all entered into a project where we don't know what the project's going to be when we have to complete it. We just put our pen to the paper and we start drawing, we start thinking, we sleep, we come back, we critique, we talk, we do this over and over and over again. And I, as well as when I teach, I constantly have to remind my students, like, look, you're not going to get it right the first time. It's only going to be through this process of usually talking to yourself through drawing and then talking to other people through that drawing, communicating basically, that you're going to get there. So I think it's part and parcel with the enterprise. I think it's really a critical way of thinking about how we actually make things is through communication, as opposed to just sort of imagining it appearing, let's say.
That's right.
I think that to that extent too, like, we're talking about technology. Technology is just a tool for you to do that. What you do with that tool is up to you.
Yes, exactly. And I think that some people, when it comes to analog techniques, I think that the time required to complete the representation with the analog technique and then to review it and move on to the next thing, because it's so much more time and it's compressed down through, computation, that creates the space for thinking. And so yes, like, I think arguably it's kind of like, you gotta, if you're taking a new racetrack, you want to go through it slowly before you go through it quickly, really understand it. And so, yes, you can think through a computer for sure. You can think through a kind of process, but it presents different difficulties, although it does also present advantages in terms of how far into the future you can see procedurally and how much complexity you can manage.
But I do think language is such a interesting lens to think about, one's capacity to represent what one's thinking, right? Like we've all seen, I'm not that great at drawing, right? That limits my ability to express something form that I'm thinking on paper. We've all seen, people who are limited by what they can render in Rhino only make forms within a sense subset of what they can reasonably model. Rendering, I think, is another great place where you really see folks limited by their ability to render in order to really put what they're thinking on paper as a way, as a piece of communication. And this is where I feel working on that craft and that process remains really important. Like you have to constantly get better at downloading what's on your brain to a piece of thing that communicates to someone else what you're thinking.
But Lebo, the word that you're looking for is you need to be articulate. And that's the same as in verbal language as it is in visual language too. And I think the only way you can get better is by practicing. I'm constantly surprised at how many people shy away from technology because they don't find it approachable in the first place. The funny thing about technology is if you open up your computer and you do something and it looks terrible, you can just shut down your computer and walk away and no one's going to look at it. So you can keep on trying and trying and trying until you get it right. But yeah, I do agree that, part of this discussion is really about how articulate we can be with our work. And if we make articulate drawings and articulate visualizations, then we can make really nice buildings and spaces probably too.
Yeah, I heard, I used to work at Thornton Tomasetti, and I heard a quote. I don't know if it's apocryphal, but my boss, Prabhotani, who's I think the CTO there now, runs the AEC Tech conference, told me once that the Lever House had, like the total drawing set of Lever House was like in the hundreds of drawings, like maybe 100, and I think he had some number for it, like 125. I hope I have that right. And then he pointed over to some skyscraper that TT had done that's under construction, and he said that building has 10,000 drawings. Now, it's so what does that say? I mean, I think it says that that production is a lot cheaper. Perhaps like, details, you can express more aspects. Perhaps you can create more room for customization with that. But also, I also feel like parsimony is important as well. Like articulation and parsimony being on these two sides of the scale. You want to target something specific, but you also kind of like, I don't know if it's, isn't it, if you Google this quote, I wish I had more time to write a shorter letter. I think it's either Mark Twain or Pascal, right? I can't remember which one. This is why you can't take any trivia. But that's on the other hand, like parsimony, compressing it down, simplifying it. Like I love that 100 drawings building. Can you get it down to one drawing? Can you record a 3-minute song and then repeat this instruction set to build a building? I find these things really, really interesting to think about.
Is that something you deal with in your own work right now?
No, it's not. To me, it's really my work now at NVIDIA is kind of like applying USD in these different contexts for these different challenges in different industries. But like every software engineer, it's a lot of like, why isn't this compiling? Why is what is this bug?
Wait. Before we move on, USD means US dollar in my world. So can you please explain?
So that's why they put the prefix Open USD on it. But it's universal scene description is USD, and it was a technology invented by Pixar to solve the interop problem, and as well as I mentioned before, like the unforeseen like changes and dynamism within producing a movie, so that these changes in like Buzz Lightyear's helmet can be slotted in, and then the render could be propagated downstream without anyone having to take something apart and rebuild it. So it's this way it's a framework and a file format for composing all this different information in a way that fosters collaboration and computation.
Yeah, I think anyone who's, I guess, producing architecture today is probably familiar with the problem of interoperability, right? It's when all the things are using speak different languages and you have to export it in one format, import it in another, redraw some parts that don't get translated correctly, and then do it again and again and again until you get kind of to the final product. So part of, I guess, what you work on is bringing OpenUSD to the production of the built environment. Can you tell us like what that unlocks for someone who might be struggling with this today?
Yeah. So we are with regards to the built environment, I think that as it stands, OpenUSD's use cases kind of dwell more on the production side, rather than the digital twin side,
Mm-hmm.
with regards to maybe what architects are more interested in. But I could tell you in manufacturing, for example, what it brings is the a easier way to compose what would otherwise have been a very challenging combined model of many different kinds of assets from many different kinds of platforms, with which you can simulate outcomes such as what will happen on the production line if this error occurs, or how can we optimize this. And it gets back to our language discussion a little bit, because like BIM, I think that the semantics of things in one environment, and that the ability to compute with semantics becomes an ontology becomes a big part of the value add in USD.
So there's a lot of compress in there, right? There's semantics, ontology, and then kind of compressing those two. Can you like, I guess, give us a play-by-play breakdown of what those three things are, and how does OpenUSD bring them together?
Sure. Yeah. So ontology. So for those of you that have, used BIM, or maybe don't even know what Revit or BIM is, the killer feature of it is that instead of making a rectangle in CAD and calling it a door, the door itself is like the first class citizen. It's the thing that you add. So every part of a building kind of has its own class, as we would say in object-oriented programming. It's its own thing. So its information, what it is a key part of it, versus in a purely CAD program, a rectangle is purely what it is as is expressed geometrically. And this is important because a lot of the things that we care about downstream are how many desks do we have in a WeWork, right? And actually, if you produce a design purely out of rectangles, your rectangular columns and rectangular windows, and you had to select like a kind of machine vision problem, all the desks in your Rhino model, but you put everything on the same layer, you might find it a little bit challenging, unless you have very strict rules for how you model those desks. So it's important to use ontology to make sense of what the parts of the building are, but also to produce more data products, use the information attributed to those things to simulate, to make predictions perhaps about cost. So yeah, it's the combination of the drawing of buildings and data.
Wait, hold on. So you used object-oriented and then used ontology. Are you a triple O? Are you talking
Oh
about
my God. No,
ontology with regards to Revit?
I'm glad you mentioned this. Yeah, triple O. It's something, that's for sure. Yeah, I went to 2 triple O lectures. I was curious about it. Yeah, I think that if I go about this another way, I think that there's 2 applications of, or maybe form factors of architectural theory that are important for students to understand. And I think I have a note. So you're going to have to edit out this awkward pause while I find my little note about this. Sorry. Right. So they're like these 2 islands. One has to do with how you interface with architecture procedurally. How do you generate architecture? And the other is trying to grasp at the cognitive experience of architecture. So for example, for the former, if you read Michael Speak's Design Intelligence, that's kind of like a method or procedure for looking at architecture. He's talking about here's a method and procedure for intelligence gathering in the war on terrorism. And perhaps that's a modality that you could apply to creating an experience or an architecture. It's this about half truths and such. And then that's a pretty interesting way of looking at it, but it's kind of like a story of coming up with something. It's generative in a way. The triple O stuff, as far as I understand, is about it's philosophy kind of trying to fill in this gap where I guess cognitive neuroscience or this kind of stuff has not filled the void, which is your phenomenology, which is what are you experiencing? What is the effect of the cause of architecture? And I think that Triple O is arguing that the information, it's metaphysics, like the information that is present in objects that are discrete is more real in some sense, or the concept of the thing is more real than the thing in and of itself. And I think that we understand this as like a programmer when we create something, but I do not know how that, my problem with Triple O is like, and then now what, like what does that mean? When I don't, let me put it this way. If I used Triple as a framework for creating a building or understanding a building, I don't think, your regular Joe or Sally is going to walk into that building and be like, whoa, like that information is really instantiating itself like across space and time, like, forgive me maybe for like missing some of like the finer points of Triple O, but you know what I mean, right? Like,
Yeah.
I don't see how this connects with experience. And therefore I think it's just more of a fun thing to know for trivia versus something that would actually be useful in your, practice.
Sorry to throw this. I did not anticipate this conversation going this route, but I think it was interesting that you're using this terminology to talk about software. My also understanding of Triple O object-oriented ontology is that we need to sort of, let's say, preference or make prime the object as opposed to subordinate the subject. Or sorry, subordinate the subject in this case, as opposed to subordinating the object under the subject. So it also has a lot of relevance, I think, in the where we think that everything is caused by humans. And then one can also sort of look at the reverse and see how humans are reacting to everything that is happening in the universe. I don't want to like waylay our conversation here, but I just thought that was really interesting, Leland, that you use those terminologies.
Oh yeah, no, that's great. And I think people should at least get in contact with what's happening in the discourse just to stay relevant and make up their own minds.
But I do think software, it might be a little bit closer to that. Like the language and the design and the conceptual framework that builds software is a lot closer to kind of that philosophical foundation than maybe the design education. I feel like we express these things, we talk about these things, but we don't actually apply it in practice as much as I feel like in software practice, it is much more embedded in the craft, in the practice.
Yeah, for sure. I mean, last year, I like to throw little like software engineering like tidbits and like puzzles and stuff to my students sometimes. And last year, explained like a very basic how compression works, like a basic understanding of how compression works. And compression is a good example of this idea where basically anything that's repeated in like an image or a piece of text is only written once. And then what you do, it's like a block instance. You put the index or some identifier for that thing in place of the object itself. So instead of having like all of the data that represents red, you write red once and then you put like a 0 everywhere where there's red. You know what I mean? And so in that sense, like that's kind of metaphysical because like the information is the thing that exists. And then the instantiation in the thing itself is just an interface back to that more real kind of core information that it's referencing.
But beyond just the fun problem, like compression has really tangible effects, right? It's what makes your computer smaller. It's what makes your internet seem faster. It's what makes data centers smaller. Like they have
streaming, video, etc.
Yeah.
This conversation, everything.
Yeah. It's what enables, us to be in, I guess, 4 locations across 3 cities and have a real-time conversation.
But are you guys saying that in tech, this sort of philosophical conversation has much more important real-world consequences than, say, when we tend to think over, sort of conceptualize and theorize in architecture?
I think what I mean to say is that in tech, maybe you're in closer contact with these philosophical kind of ideas because maybe it's the medium of like bits versus atoms that you can really like play games with what's real, what's not. You're structuring information. I think that's all I need to say. I don't know if like a program from the end user's perspective has more of an ability to convey these ideas. But certainly in making it, I think that you can exit normal.
I do think it's also comes from, I guess, a lack of history, right? Like buildings have like a lot of this historical, I guess, embedded information built into the practice. But I guess, you know, in terms of designing databases, right, you are in a way designing these ontological systems that have an end effect. Like, how do I query and ask the right questions, and how do I get it back the fastest? That's kind of organizing these abstract objects in a way where you can connect them in the right ways to answer your question. So the design does have, I feel like, a much more impact on the effectiveness of what you're doing, but also much more, there's much more flexibility in how you define that, right? Like, I feel like, you know, architects like to say that a slope is, you know, both a ramp and a chair. But the the effect of that is much less usable than, say, you know, a database design.
Yeah, I strongly dislike sitting on slopes. I really try to avoid them. Yeah, actually, ontology does break, you know, for some architects who we may know, where, you know, wall becomes roof, becomes wall again, becomes column, etc. You know, where's the column stop? Where's the wall start, etc. But I think that the edge cases are probably fewer than in the real world, because at the end of the day, we have to produce the instructions. We have to have an economy of manufacturing. So, you know, things do have names and things are productized, at least until everything is 3D printed, or like, you know, it starts to look like StarCraft 2, you know, Terran construction, where there's like a bunch of gantries and stuff, and it's sick as hell. But not yet.
Did we cover everything about the OpenUSD that we want to get hit? I'm still confused about it.
Yeah, it's understandable. It's very powerful, and like all powerful things, I think its form factor is still underway and changing. The Alliance for OpenUSD came about recently, so now, you know, a larger kind of consortium, a group of people are looking at and agreeing upon certain standards. But what's coming around the bend is really great, you know, handling like BREPs and stuff, solid, you know, other kinds of modeling. More schema and ontology is coming for sure. So yeah, I think that first, it's kind of like when new technology is made at NASA, and then in the future it kind of descends upon you know, the regular consumer. And I think that its application in robotics and manufacturing and self-driving vehicles and stuff like that, really cracking open some of the issues there in simulation, and then later, you know, hopefully in the near future, descending upon the architecture field and having a more understandable and tangible interface, for sure.
Yeah, so I just
I
want
think
to
it would be
clarify.
useful to know.
Yeah, so basically it's allowing for new forms of geometry to manifest in the real world. Is that right? That you can manipulate geometry in a way that is more
But I think it's
precise?
more like a dictionary, right? Like, all these file formats are these different dialects of potentially the same language. Like, when you see it on a screen, they're all 3D, but underneath, like, each individual, like Revit has its own way of representing it, like 3D Max has its own way of representing it. But OpenUSD is really, I guess, this dictionary standards, like, hey, this is how you can represent 3D information, and you need that language to be adopted the same way across all of these platforms in order for them to all talk to each other in the same way.
Gotcha.
That's right. The interop is one of the killer benefits, and also the fact that it does interop, I think, better than any other platform or file format because of that layer system, where you can have what are called opinions, where you can have your, you know, let's say you have a complex of multiple buildings going on site, and you have your simulation environment of your site, your new urban development. Each of these different buildings want to live in different files, perhaps in Revit. So you want to have a process for, if a change is made, let's say to that building, to bring it back into this environment. But then you might have an opinion applied to that export of, okay, where does it get put on site? That way, that information doesn't have to live necessarily in each independent Revit file. So these layers of, like, what are called the composition arc, you can slip in all these little changes and adaptations, you know, replace all the glass with this glass material now that we're using, which, you know, has the right properties for doing, you know, this particular simulation. So I think that the way to look at it is it's the best way to put together all of the information from these different contexts in a way that handles, like, the dynamism of a collaborative process as well.
Right. And so the downstream effect is that you would just have a much smoother process and therefore better outputs. Gotcha.
Yes, and then really good performance with regards to actually wanting to create applications that leverage that composite. And yeah, we're on the cutting edge in the beginning of this journey, and making decisions about ontology and schema and stuff like that. But everything is looking extremely positive from my end, and I'm just really eager to see like this becoming a part of the architect's tool set as it reaches a higher level of maturity.
Maybe one thing you can kind of give us an insight into is like what kind of industries are represented in this consortium that's kind of defining the standard. Because I think one of the great promises of OpenUSD is like it's able to bring all these things together in a digital 3D environment, very much like our real world, right? When you build a building, it's interacting with all these other things in 3D space, even though it might not be designed with the same context in mind, right? It's just in this environment. So how do these different industries see it valuable for them?
Yeah, I think that, standardization is a huge part of opening up opportunities downstream. I think that the world is a better place because of something like USB. I think it like opens up the world for new businesses. Just to say that this is the rectangular port that all computers, we're going to agree upon this, except for the latest Macintosh. But yeah, you know what I mean. So I think that it's like standardizing anything. I think it has benefits for an industry, and I think it's a great thing. I can't tell you because I don't work with the Alliance for Open USD. I don't know or remember who's there, but I know Autodesk is a part of it because USD interops with a lot of their program platforms. But there are a lot of voices at the table across architecture, special effects, and movies and entertainment that are discussing these things and making timely decisions about what USD can do and compute and what should be what and how it should do it.
We talked about maybe several camps within design, the more traditional analog one, and then the one that's a little bit more forward thinking, more open and friendly towards technology. How would you appeal to, let's say, the original one, the sort of establishment with regards to your work and how it's going to affect outcomes for architecture moving forward?
Yeah, I think I need to better understand where they're coming from. So I have like a general way. I have a general way of thinking about it, and then maybe something a little bit more specific to a certain mindset. The general way I see this and how I would appeal to them is that simply don't knock it until you try it. I think you should become competent at it and then decide that it wasn't the right path. I think like perhaps apocryphal stories about like painters, they become the realist painters, but then their career is really successful in abstraction. And I think if you're going to go into abstraction, I think you should understand the opposite of what you're doing, what you're leaving behind, because that's part of your voice. I don't think you can have a voice in a articulated voice, to use a word, without considering, what is being omitted by not leveraging technology, since it's so pervasive. So I think that the other thing to appeal more specifically to a certain mindset is I would never define my corpus as I'm the person that doesn't do this. I wouldn't open a restaurant across the street saying we're better than the one across the street, go to us. People should show up because what you do is great. And if technology is what makes it great or is a part of it, then yeah, embrace it. But if you don't think so, if it's more, I guess, traditionally artisanal and very handmade, then yeah, that's your strength, and that's why people should come and enjoy the work. So yeah, I wouldn't define myself or define a practice by turning my back on technology without understanding it.
I think that's a great note to ask our final question that we're starting to ask all of our guests. One of our goals with this podcast is to kind of understand the era that we're in through your perspectives. We feel that we're a little bit past the postmodern era and we're not really sure what comes next. So this is why we call this podcast Most Modern. So our question to you is, from your perspective, what defines the era that we're in?
Yeah, super unclear, but I think that there's a reasonable way to go about answering this question. I think we live in everyone should look up Kevin Slavin or Slavin, Slavin. He gave a really famous TED talk like a decade ago about how algorithms shape the world. You could start there, and he has a couple other talks. He taught at NYU. I think he taught at MIT or something like that. I've listened to pretty much everything, and he said, and he put this really well, that you don't have to go into solving a problem anymore with a theory. You just need the data. And so I think that we are, in a way, when you look at especially ChatGPT, there's the transformer perspective, which is that you engineer a framework for consuming information, reformatting it. But ultimately, it's the quality and the corpus of data that produces the outcome. So a kind of post theory might be one way to go about it. Why you can crack open so many games, you don't even have to have a theory anymore. You just have to collect 1,000 rounds of solitaire to understand solitaire. I think that's the example he gives. So that's one. I don't know what that really means. Maybe it has to do with design spaces and stuff like that, and algorithmic generation. But somehow that also doesn't fit, because I think that our time today is also very disaggregated. We always talk about the creator economy, and how wouldn't it be better if instead of having 3 major channels, we had 3,000 creators that were creating content just like yourselves. And I think that disaggregation has for sure been beneficial to spreading well-being around. Also putting new voices, and I think we can do an even better job in platforming new voices. But I think that the disaggregation kind of makes it difficult to sum everything up, and to provide a general picture for how things are going. So it's highly individualized. And when I consider the end game of that, I feel, and I don't know if you guys feel the same way, perhaps it's a post-COVID thing, but yeah, people are really eager to get behind big uniting events. I feel the hunger for something where time stops and everyone's watching, the ball drop in Times Square, or everyone's going to a Taylor Swift concert or watching the World Series, something like that. I feel the hunger and the appetite for unity in an experience is never been greater. And maybe I'm just getting older, and that's also maybe the way you feel. So all these ideas I'm wrestling with, and I'm not sure if any of them resonate with you guys.
No, I love it. I mean, I like especially your last point about the hunger for unity. I mean, I feel that we definitely felt, everyone who's gone through COVID, through that pandemic, knows what it's like to be completely isolated for a long period of time, and how valuable being around other people or around something that is bigger than any one individual. So I'm particularly fond of that response.
And I think that resonates with kind of the mission of this podcast. When we first got together and talked about how disaggregated our industry is, we architects talking to architects, developers talking to developers, construction folks talking to construction folks. And part of what we feel is we don't know what that unifying voice looks like, but it's worth pursuing and worth trying to get there. So that's part of why we try to do this every week, bring someone different with a different perspective to try to help us find what that is.
Cool. I didn't know you guys do this every week. That's a lot of listening. I give you guys credit.
Well, there's 30-something episodes of back catalog you can listen to if you're interested. But thank you again, Leland, for being our guest on this episode of Most Modern. I think we took some twists and turns in that conversation, but we covered a lot of really great ground, and I look forward to listening to this when it comes out.
Yeah, I hope it's entertaining, but if it is, I'm happy to come back, and it was a great pleasure to meet you guys and have this conversation.
Thank you so much.
Most modern.
Most modern.
Most modern.
Most modern. 모스트 포던 팟캐스트